Today we're going to be talking about systems of linear equations using any method. Using any method to solve these involves all the methods we've talked about in the past, which include the graphing method, where you find two lines that intersect, substitution method, where you substitute a variable in to solve for, and the elimination method, where you eliminate a variable to solve. So we're going to start off with one specific system, and we're going to use that system to solve for all three methods. So we're going to use the equation y equals 6x plus 4 and 3x minus y equals 2. The first equation is written in standard. No, the second equation is written in standard form, and the first equation is written in slope-intercept form. So when we use the graphing method, we want both of these equations to be written in slope-intercept form in order to graph. So we are going to rewrite the second equation, y equals. So we're going to take 3x minus y equals 2, and we are going to subtract 3x on both sides in order to get y by itself. This leaves us with negative y equals, we're going to put the x first because that's the form that helps us to graph. So negative 3x, and then there's no sign in front of the 2, so we know that's going to be positive. So now we're left with negative y. So we have to divide by negative 1 to get y by itself, so that there's no negative in front of that y. So negative 3x divided by negative 1 is going to give you a positive 3x. And then 2 divided by negative 1 is going to give you negative 2. So now we can graph these two equations because they're written in slope-intercept form. So I'm going to start off by graphing y equals 6x plus 4. When I graph y equals 6x plus 4, I'm going to start at the 4 on the y-intercept because I always start on my y-axis. So I'm going to start at 1, 2, 3, 4, and plot a point. And from that, my slope tells me to go up 6 and over 1 because the slope is 6. So my slope is 6, so that is really 6 over 1, which when you graph, that tells you to go up 6 over to the right 1. Well, if I don't have enough points to make my lines intersect, then I know that I'm also going to have to use negative 6 over negative 1, because 6 over 1 is 6, and negative 6 over negative 1 is also 6. So if I don't have enough points going up 6 and to the right 1, then I can also go down 6 and over to the left 1, because that's going to give me my same exact line. So from this point, I'm going to count up 1, 2, 3, 4, 5, 6 and over 1 and plot my point. But I'm also going to count down 6. 1, 2, 3, 4, 5, 6 and over 1. And again, I'm going to count 1, 2, 3, 4, 5, 6 and over 1. Because I want my line to go straight across my graph and have as many points as possible. Because I'm going to find my solution by finding out where my two lines intersect. So when I graph the second equation, I'm going to start at negative 2 for my y-intercept, and from there I'm going to go up 3 over 1 because that's my slope, or to get additional points I can also go down 3 and to the left 1 because negative 3 over negative 1 is the same thing as positive 3. So I'm going to start by going up 1, 2, 3 and over 1. And then I'm also going to go down 1, 2, 3 and over 1. Down again 1, 2, 3 and over 1. See, this helped me create more points on my graph so that I can find out where they intersect. So I can now tell that my green and my blue line intersect at the point -2, -8. So that would be my solution when graphing. Another method to use when solving this system is substitution. Okay, when you use the substitution method, you want to make sure that you have one variable that's already isolated. So we can isolate 6x plus 4, and we can substitute it in the equation 3x minus y equals 2. So instead of putting y into my equation, I can put 6x plus 4 because that is what y equals. So I'm just going to rewrite this equation, 3x minus whatever y is equals 2. So I'm going to plug in what y is, which is 6x plus 4, and I'm going to solve. I have this negative on the outside of my parentheses, so I'm going to distribute that. So I have 3x minus 6x minus 4 equals 2. So now I can combine like terms. 3 minus 6x is going to be negative 3x minus 4 equals 2. And I want to isolate x, so I'm going to add 4 to both sides. That cancels out, leaves me with negative 3x on this side and 6 on the other. Then I divide by negative 3 on both sides, and I get x equals negative 2. Since I have my answer for x, I can now use that x and substitute it into one of the original equations, the typed out equations, the black equations, to solve for the remaining variable. So I want to find out what y is, so I'm going to use x equals negative 2 and plug it in for x. And I could have used either equation, but the top equation just looks easier, so I'm going to do negative 2 in for x to solve for y. So I have y equals 6 times negative 2 is negative 12 plus 4. And we know negative 12 plus 4 gives us a negative 8. So my coordinates, when I solve the system using substitution, are negative 2 for x, negative 8. And this is the same answer that I got whenever I graphed, which it should be the same answer because we are solving the same systems, but we are just using different methods. Another way I taught y'all to solve systems is by elimination. So I can use this method to solve my system. And in order to eliminate, I have to rewrite each equation to standard form. As you can see, the second equation is already written in standard form, which, if you remember, standard form is ax plus by equals c. So I have my x, my y, and my c. So the second equation is already written in standard form, but my first equation is written in slope-intercept form, so I need to rewrite it into standard form. So I'm going to take this equation first And I want this x to be over here on the other side with the y. So in order to do that, I need to subtract 6x on both sides. I'm only doing this because I have to rewrite each equation in standard form first. So I'm going to be left with 6x plus y equals a positive 4. Now both of my equations are written in standard form, so I can line them up. I'm lining them up by term. So all the x's are in one column, all the y's are in one column, and all the numbers are in the other column. And I'm eliminating, so I'm going to put plus sign because I'm going to add each column. So I'm going to add my x column, which is negative 6x plus 3x is going to give me negative 3x. And y plus negative y eliminates. That eliminates. That equals 0. And then 4 plus 2 equals 6. So now I'm going to divide negative 3 on both sides. I get negative 2 as x. And now I can solve for the remaining variable either by substituting into one of the original equations, which can either be the first equation or the second equation. So we're going to use this go around. I'm going to use the second equation. So 3x minus y equals 2, and I'm going to substitute this x So instead of putting x, I'm going to put negative 2, and I'm going to solve for y. 3 times negative 2 gives you negative 6 minus y equals 2. Now since we want to get y by itself, in order to get y by itself, we have to do the opposite of what's being done. And in front of 6, I have a negative 6. So I want to make this positive. So I'm going to add 6 to both sides. Now I'm left with negative y equals 8. And since the variable cannot be negative, then I'm going to divide both sides of the equation by negative 1. This leaves me with y equals negative 8. So when I solved this system using elimination, I got the answer negative 8 for y and negative 2 for x. So my coordinates are negative 2, negative 8. So all three methods gave me the same answer.